The next law we are going to be looking at is the Biot Savart Law. Now, consider this wire in which current flows through it in this direction. Now, to find the strength of the magnetic field produced as a result of the current flowing through this wire, the strength of the magnetic field can be gotten using the word the Biot Savart Law. Now, consider a tiny portion of this wire. We call that portion dl. Now, the distance from this point to this point is r, and this is the position vector r. This is the unit vector r. This one tells us what the direction of this what r. Now, the strength of the magnetic field produced as a result of current flowing through this wire is gotten from Biot Savart Law, and the formula is what dB equal mu naught over 4 pi I dl cross r unit vector over what r square. Now, observe this. This one is the strength of the magnetic field if you consider it in vector form. That is, we take the cross product of the L and what this r, the unit vector r, then divided by what r square. Now, if I get this in scalar form, that is, look at this cross product. Cross product is what? Remember, A cross B is magnitude of A, magnitude of B sine theta. So the magnitude of this, I'll write it as dl. And remember, a unit vector, the magnitude is equals to 1. Then I will now write what? Sine theta. So I can deduce from here that what? This magnetic field dB is proportional to what? To the sine of the angle between this differential element and this point we want to get the magnetic field. Also, we can see that what? The strength of this magnetic field dB is what? Is inversely proportional to r square. Are we together? So that is it. Now, if I want to get the total magnetic field, that if I integrate both sides, I'm going to get this equation. And my mu naught is equals to 4 pi times 10 raised to power what? Minus 7. Now, remember, I told us something that if you want to get the intensity of this magnetic field as a result of current flowing through this wire, we make use of the Biot Savart Law. And this is the what? The formula to get the what? The intensity of the magnetic field. Now, the next thing is that what? How do we get the direction? Now, observe. Look at this pen. This consider this as a current carrying conductor. Let me assume that current flows in this direction, and I want to get the direction of the magnetic field. This is what you will do. You will grasp this conductor, grasp it this way, and make sure that what your thumb points in the direction of the current. If your thumb points in the direction of the current, automatically your coiled finger tell us what the direction of the what of the magnetic what field. Do you see that? Now let me say this is my what current carrying wire, for example, and what current flow in this direction. Now if I grasp it this way, you see that what my magnetic field will be going this way like this. Observe, like this. It will be going what this way. It means that what at this point the magnetic field is going what inward. And at this point, it's coming what? Outward. That is it. So again, if I grasp this conductor like this, you observe that what? Make sure your thumb points in the direction of the what? Of the current. Then your coiled finger points in the direction of the what? Magnetic field. So if you observe, you see that what is going this way like this. So it means that what? At this point, the magnetic field is going inward, and at that other point, the magnetic field is going what? Outward. And that is the direction of the what? Of the magnetic what? Field. So that is it.